Hi guys, I'll be giving you an introduction on how to use a multimeter. So for those of you who don't know what a multimeter is, it's a device that we use in the labs to measure, to test. So whenever we need to measure current, voltage, capacitance or resistance, we use this device to do so. And you can also use it to do some troubleshooting. So whenever you don't know what the problem is with your circuit, you use your multimeter to identify the problem. In our labs we have two kinds of multimeters. We have the grey U-Fong multimeter and then we have the orange multimeter. There's not much difference between these two other than the fact that the grey multimeter is older than the orange one. There's also a switch that allows you to either select the DC or AC function. So let's say you have to measure DC voltage, you will then switch to the DC function. But on our orange multimeter, there's this dial selector that allows you to either choose between the DC or AC voltage function or the DC or AC current function. And then on our grey multimeter, there's also a function that allows you to measure the current gain of a transistor, but on our orange multimeter there simply isn't a function like that one. So now I'm just going to be briefing you guys on all of the functions that are found on our multimeters. We have the continuity diode function that allows you to do the continuity or diode test. We also have the ohm function that you'll use whenever you are measuring resistance, and it ranges from 200 ohms to 200 mega ohms. We have the DC voltage function that can be identified by a symbol that contains a straight line with 3 dots at the bottom. This function ranges from 200 millivolts to 1000 volts. We also have the AC voltage function that ranges from 2 volts to 750 volts. Next we have the AC current function that ranges from 20 milliamps to 20 amps, and then we have the DC current function that ranges from 20 milliamps to 20 amps. At the bottom we have 4 terminals. So the first one, which would be on the right hand side, would be the volt ohm terminal, and you'll use this terminal together with the common terminal, which is the black one, to measure voltage, resistance, or do the diode or continuity test. Then we have the milliamps and 20 amps terminals that you'll use together with either one of them. You'll use together with the common terminal to measure current. So whenever you use the milliamps and common terminals, you'll use these whenever you need to measure a current that is less than 200 milliamps or equals to 200 milliamps. If you have a current that's more than 200 milliamps or the current is unknown, you would use the 20 amps terminal together with the common terminal. So just to add to that, whenever you have a current, a voltage, or a resistance that is unknown to you, please make sure that you select the highest scale of that function. So for example, if you're measuring a resistance and you're unsure of, or you don't know what the resistance of the resistor is, you would then start at the 200 mega ohms scale and then decrease your scale if need be. So for the continuity test, we usually do this test to determine if there's a connection between 2 points. And how you would go about doing this test is by inserting a red lead into the volt ohm terminal and a black lead into the COM terminal. After doing that, you use your dial to select the continuity function, and then you turn your multimeter on. If your multimeter is on, you touch the ends of your leads together to see if there's a sound. If there's no sound, it means that your leads are faulty or it's not inserted correctly. So whenever you have to do the continuity test, please look for a symbol that looks like a Wi-Fi a Wi-Fi symbol. So yeah, that is the symbol of the continuity function. So here's just a short demonstration on how to do the continuity test. So like I said, you insert your leads, you change to the continuity function, and you touch the ends of your leads to get the beep sound. Whenever you're using a multimeter and you see BET displayed on the gray multimeter or a little battery symbol on the orange multimeter, just notify the trainee in your labs, because this means that the battery is flat, and if the battery is flat it could lead to you taking wrong measurements. So if it's displayed on your screen, just notify one of the trainees and they will give you a new multimeter.
Hi guys, on this slide I'm going to talk about the resistor. As you can see, there is a resistor in front of you. That's a 4-band resistor, and there is a resistor symbol as it's shown on the circuit. So the basic understanding or the basic concept behind the resistor is that it's an electrical device that is used to reduce or to resist the flow of electrons or to resist current. So what happens when a current goes through a resistor? A resistor will always, or it will make sure that it cuts off all the excess current that probably, let's say, a component that is connected on our circuit needs a certain current. So a resistor will make sure that that component doesn't get a current that exceeds the value that it's required on that component. So a resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. What do we mean by passive two-terminal? As you can see, that resistor, it has a wire on the side and the wire on the other side. So the current can pass through from any direction. A resistor doesn't have a polarity, so you can pretty much connect it any way you want, as long as you're going to connect it correctly on a circuit. So in electronic circuits, resistors are used to reduce current flow, like I said in the beginning, and adjust signal levels. If you have signals that have high pitches and you want to reduce the pitch, you can use a resistor. Also to divide voltages. So if you have a high voltage through a resistor, there's obviously going to be a voltage drop. So in fact, not through, across the resistor there's going to be a voltage drop. So the resistor will help you to reduce that voltage, as well as biasing active elements and terminate transmission lines, amongst other uses. I hope you guys understand that. Now let's talk about a resistor box. As you can see in front of you, there's a box full of resistors. That's how it looks on the inside. That the resistors I'm talking about. Those resistors are rated differently, and when we ask you to measure the resistance across, let's say R1, because there, as you can see on the magic box or on the resistor box, is that the resistor values are not written there. So you just get your R1 up to R9, and then we'll tell you to measure the resistance across whatever terminal that we want you to measure in, and you'll write that value down, or maybe you'll connect that resistor in a circuit. You can build a circuit as well with the resistor box. So I hope you guys have an idea now of what a resistor box is and how resistors are, and you can also connect the resistors you see there either in parallel or in series. So I hope you guys get it. Let's talk about measuring the resistance. So whenever you are measuring a resistance, there's some few steps that you have to follow, and you have to make sure that you follow those steps correctly. The first thing you do is to select the highest scale on your multimeter, meaning that you set your dial selector to the highest resistance scale. The reason for this is whenever you are measuring an unknown value in a multimeter, whether it be current, resistance, or whatever, always make sure that you select the highest scale to protect the multimeter. Then from there, you'll take the red lead, you put it on the volt ohm terminal, and you take your black lead, you put it on COM. From there, then you will put your other ends of the leads across the resistor. If you switch on the multimeter and there's no reading displayed, then you select the lower resistance scale by turning your dial selector to a lower scale. You do that until you get the value that is within the range of your multimeter or of the scale that you are measuring. Say maybe you are measuring 100 kilo ohms resistance, and on your multimeter there's no 100 kilo ohms, but there's obviously 2 kilo ohms. Then you know your 100 kilo ohms is within that scale. And if you go even further to a lower scale than the one that you are measuring, you'll obviously not get anything. On the gray multimeter you'll get 1, or on the orange multimeter you will get OL. Whenever you are measuring your resistance, make sure that you put your values in engineering notation. What do I mean by that? In front of you, we have measured a resistance and we got 0.986 kilo ohms. As you can see, the scale is on 2 kilo ohms, and that value is below 2 kilo ohms, but it's above 200, because at the bottom of your multimeter it's written kilo ohms there. So now let's talk about converting that value into engineering notation. So you go to your calculator, you punch in the value that you have, and you don't forget the units. You punch in that value is 0.986, exponent 3, because it's in kilo ohms. Then you punch in equal. Then the value that you get there is 986 ohms. Now, in other cases, you won't get a value, and that will come up is like that. So you get a value that starts with 0 point something and the scale is different. What you need to do is that you need to punch in that value and write in the multiplier, which is, say maybe it's mega ohms or it's whatever. Once you write that, you press equal, and then on your calculator you go to eng. There's a button written eng next to RCL. You punch in that button, and then you will get your value in engineering notation. It will be something times 10 to the power of something. Then you know that's how you will write your engineering notation, because times 10 to the power 3 is kilo, times 10 to the power 2, and so on and so on and so on. I hope you guys understand that. Now let's talk about selecting your resistors. You have your resistor pack, or you have your component pack, and you wanna use a certain resistor, but you don't know the value of that resistor. or you know the value of that resistor, but you don't know how it looks like, I mean. So in that case, that's where color coding or resistor color coding comes in. In your resistor color coding, in fact, in your resistors, we have like different types of resistors. We have a 4-band resistor, we have a 5-band resistor, but we are using the 4-band resistor, meaning that we'll use the one on top with a tolerance of plus minus 5%. In some other cases, the tolerance is plus minus 10%. So how you actually select your resistors is by this. There we have an example of 270 ohms resistor. The first two values on your resistor are actually the first two bands on your resistor. So on that resistor, we have the first band being red, the second band being violet, the third band being brown, and the fourth band being gold. So the fourth band is the tolerance. So the tolerance is usually written down. So there at the bottom of the table, there's gold as well as there is silver. That's your tolerance. It's always your fourth band. You'll always see your tolerance on the fourth band. So as I was saying, the first two numbers are actually your first two bands. So let's go to your table. Our first number is 2, and on the table 2 is red. We have a red band. Our second number is violet, which is 7, and we can see that 7 is violet. Then the third number is our multiplier. What do we mean by that? On the third value, that's where we actually count the number of zeros that we have. So after that 27 or that 27, we have 1 0, which means our multiplier has a power of 1. As you can see, the multipliers there, it's 0 up to 9 for the colors, or for the first 3 bands that we use in our resistors. So that 0 is actually our multiplier. So now let's move on. Let's say maybe on that 5-band resistor, it was a 4-band resistor like we have, but the value is still the same, which is 100 kilo ohms. So now let's look at 100 kilo ohms. 100 kilo ohms is actually 100,000, meaning that there's how many zeros? There's 5 zeros. It's 1 and 5 zeros. So we said the first two bands actually are our first two values. So the first band is 100, is 1, I mean. So our first band would be black. The second band is 0. So our second band will be black. It's brown, black, I mean. Our first band is brown, our second band is black. Now, how many zeros we have now left? We have 4 zeros. So we go to our multiplier. We look for where there is a power of 4, and we see that that yellow has a power of 4. That means our resistor will go like brown, black, yellow. That's our 100 kilo ohm resistor. I hope you guys get that.
Hello, I come back. So guys, I will be explaining to you guys how to measure voltage. For those of you guys who don't know what voltage is, let's look at voltage as water pressure. So let's say we have a tap and we have a hose pipe, and we connect these two together. So if we open our tap, or the more we open our tap, the more water pressure we would have, and our water would then flow fast. But if we now decide to close our tap, we would have less water pressure and our water would start to flow slow. So we know that voltage is directly proportional to current, which means that if we increase our voltage, we increase our current. If we decrease our voltage, we decrease our current. But if I now decide to step on the hose pipe with my foot, so let's look at my foot as the resistor. So if I decide to step on the hose pipe, it means that I'm now restricting the flow of the water. And if I restrict the flow of the water, it means that I'm restricting the flow of current. So anything that restricts the flow of current is known as resistance. So I guess I just explained Ohm's law to you guys. But yeah, let's get on with the PowerPoint or the slide. So the first thing that you'll have to do whenever you're measuring voltage is that you would have to first determine if you are measuring an AC or a DC signal. So if you are measuring an AC signal, you'll then have to set your multimeter to the AC voltage function, and then if your voltage is unknown, you select the highest scale of that function. But if it is known, you can simply just select the scale that is appropriate for it. But as I said, if we now decide to select the higher scale, you can then decrease your scale if need be to get a more accurate value. So on our left hand side, we have an illustration of a circuit, just a simple circuit. We have a resistor and we have a power supply. So in order for you to measure the voltage across the resistor, you would then have to connect your multimeter, which is the volt ohm terminal of your multimeter, to your resistor, one leg of your resistor, and then the COM terminal of your multimeter you then connect to the other terminal of your resistor. So I'm just going to be opening a video on how to measure voltage, and in the video we have a power supply and we have a multimeter. So we connect our multimeter to our power supply, and we would then select the accurate scale. So if I say I want 12 volts on my multimeter, I decided to choose the 200 volt scale. And like I said, in order for you to get a more accurate value, you would then have to decrease the scale. So I took it to 20 volts. And note how 12.1 volts changed to 12.19 volts. So after decreasing my scale, I then decided that I'll leave it at 11.96 volts from my power supply. I then connected my circuit and I connected my multimeter across the resistor. After doing so, in order for me to get my voltage across the resistor, I switched on the power supply and my voltage across the resistor was 11.9 volts. So the voltage of our power supply was 11.97 volts and the voltage across the resistor was 11.9 volts. So clearly there was a voltage drop. Okay, so to move on, so now we'll be focusing on how to measure current. So the first thing that you'll have to do is you'll have to determine if you're measuring an AC or a DC signal. If your current is unknown or more than 200 milliamps, you'll select the highest scale, which is 20 amps, and then you insert the red lead into the 20 amps terminal of your multimeter, and the black lead would then go into the COM terminal of your multimeter. Please note that if you select the wrong scale, you will blow the fuse in the multimeter, which would then lead to, or might lead to, you damaging the multimeter. If you know that your current is less than 200 milliamps, you are allowed to use the 200 milliamps scale as well as the milliamps terminal in your multimeter. So you'll plug the red lead into the milliamps terminal of your multimeter and the black lead into the COM terminal of your multimeter, and you also select the 200 milliamp scale. If your current is less than 20 milliamps, you are allowed to select the 20 milliamps scale, but only if need be. So the circuit on the left is an illustration of how to measure current. Please note that the circuit and the one from a few slides back where we had to measure voltage is not the same. That circuit was made out of a power supply and a resistor, and our multimeter was then connected across our resistor. But in this circuit we can clearly see that our multimeter is a part of the circuit. So this is actually a very important point for when you have to measure current. You have to physically break your circuit, meaning that you have to now include your multimeter into your circuit. So now I'll just be playing a short video on how to measure current. So first you have to connect your circuit, and then connect the 20 amps terminal of your multimeter and the comms terminal of your multimeter to your circuit. Then you select the higher scale, which is 20 amps, and you wait for your result as you switch on your power supply. So our current was 0.15 amps. With regards to the engineering notation, this will then be read as 150 milliamps, and we can clearly see that the current that we got for this circuit is less than 200 milliamps. So we can actually use our milliamps terminal to measure the current and get a more accurate current value. So in the next slide I would then demonstrate how to measure current using the milliamps terminal of your multimeter. So the video in this slide would serve as a demonstration on how to measure current by using the milliamps terminal. So I took the circuit that we used in the previous slide, and all I did was I changed the lead from the 20 amps terminal to the milliamps terminal. And since our current in the previous video was 150 milliamps, I can clearly use the milliamps terminal to get a more accurate value of our current. So I'm just gonna go ahead and play the video. So like I said, you plug your lead into the milliamps terminal, you select your 200 milliamp scale, and now you get a more accurate value. So we went from having a current of 150 milliamps to now having a current of 142.4 milliamps. So we can clearly see that changing from the 20 amps terminal to the milliamps terminal allows you to get a more accurate value, only if your current is less than 200 milliamps though. So yeah, that's it for current.
Okay guys, now let's talk about the diode. A diode is a semiconductor device with a single PN, which is positive negative junction. It can conduct current in one direction while blocking the current in the other direction. So firstly, what do we mean when we say it's a semiconductor? A semiconductor is a material that conducts electricity as well as acts as an insulator. So a diode conducts electricity. Obviously we use it for electrical purposes, but it allows current to flow in one direction, meaning that our current will flow from the positive to the negative, from high concentration to low concentration. So our current will flow from the anode towards the cathode. But if you turn your diode around, or you want the current to flow from the cathode to the anode, that current will be blocked in the PN junction, because the current through this diode can only flow in one direction, while there's other types of diodes like a Zener diode where current can flow in both directions. But our standard diode, or the normal diode that we have right now, only allows current to flow in one direction. And in the next slides we'll see how we actually measure a diode, how we forward bias a diode, and how we reverse bias a diode, as well as in the multimeter, how we can actually get the value we want for our diode in fact the standard value for the diode where you have to measure your diode is between 0.6 volts and 0.7 volts. Now we're going to talk about diode measurement whenever we want to test a diode using a multimeter. So the first thing, you take your red lead, you put it on a volt ohm, you take your black lead, you put it on cohm, then you change your dial selector to the continuity scale. From there, you'll see that there's actually two things you can measure. You can measure your continuity, as well as you can also get your diode. So again, on your multimeter, there's two buttons. There's a power button and there's a hold button. This is on the orange multimeter, I mean. So on that hold button, you press once, then you'll see on top of your multimeter is going to display a diode. Then from there, you put your red lead on your anode side and you put your black lead on your cathode side. That's you forward biasing your diode, and once you do that, it's going to display a value that is between 0.6 volts up to 0.7 volts. Then after that, you can change your leads and swap your leads. You put your black lead on your anode, you put your red lead on your cathode, and on the gray multimeter it will display 1, while on the orange multimeter it will display OL. And you can even do that using an ohm meter or putting your multimeter on the resistance scale. Remember, you don't know the value of your resistance, so you put it on the high scale. So once you do that, you'll notice that a diode has a relatively low resistance when it's forward biased, meaning that you'll get a value when it's forward biased, or you'll get OL. Then when it's reverse biased, you'll get a very high resistance. Your resistance will be very high. I hope you guys understand that. That's another trick of actually measuring your diode. Remember, a resistor doesn't have a polarity, but when you are measuring a diode and you play around, you change your polarities, then you will be able to identify your diode, because you'll get two different values when you swap your cables or you swap your leads around. So on this slide, I'm showing you how to measure a diode. As I've said on the previous slide, everything is there. You put your dial selector on your continuity scale and you press hold. Once you press hold, it's going to show you a diode sign, as you can see there on top. Then your red lead is on volt ohm, your black lead is on common, and then on your diode, your red lead is on the cathode, it's on the anode, your black lead is on the cathode, as you can see, and the value that's displaying there is 0.734. That's the value of your diode. It should be between that 0.7 and 0.6. So if I were to change those leads or to swap those leads, then I'll be getting OL. That's how you measure your diode. I hope you guys can see that. Now let's talk about a transistor. These two things must come into mind whenever we are talking about a transistor: amplification, rectification. So we use a transistor to amplify waveforms as well as to rectify our waveforms if there are harmonics in the waveform. So there's also like two different types of transistors. There's a PNP and there's an NPN. I'm gonna talk about those as we go by. So a transistor is a semiconductor device that is used to amplify or switch electronic signals and electrical power as I said, for amplification. Say maybe you have a waveform, or let's say this, ne? We know sound travels through waves. If you have a radio, and on your radio you are listening to whatever you're listening to, and you decide to turn up the volume, that is you amplifying that sound, and a transistor is responsible for that. Another example for the rectification, say maybe you are taking a picture, you have your camera, like there's times where you'll see that the picture is blurry. So when you have a blur picture and you're trying to fix that focus on your camera, that focus is you actually rectifying the waveforms that are coming through the lens, so that you can get a clearer vision. So a transistor is responsible for all of those things. So right in front of us we have a PNP transistor. A PNP transistor is noticeable by having the arrow that's from the emitter to the base. As we can see there in our drawing, we have a collector, a base, and an emitter. So a PNP has the arrow that's coming from the emitter pointing towards the base. That arrow actually indicates the current flow. So the current flows towards the base in a PNP. Now, an NPN, on the other hand, has the same arrow that's pointing towards the base, but on the NPN it's pointing away from the base. So you could say that the current is moving away from the base on the NPN transistor. I hope you guys understand that. We can measure the current gain of our transistors, whether it's NPN or PNP, but we can measure it on the multimeter. We use the gray multimeter to do so. So what we can do, or what we do, is to set our dial selector to HFE, and then there's slots on the multimeter where you can insert your transistor. They are labeled base, collector, and emitter. So if you set or you select your NPN on the multimeter and you put your, or you insert your transistor and you're not getting a value, you change the scale and you put it on PNP and you do the same, and you're getting a current gain of somewhere around 200 and something. There's always gonna be a current gain that's over 250, I think. And then if you see the current gain being displayed, then without you removing the multimeter, you can easily identify, okay, this is a base, this is a collector, and this is an emitter. And then from there you can build your circuit. Now on the capacitor, I usually say that a capacitor is that lazy cousin, because while other components are working, a capacitor is not working. In fact, it's charging. The moment other components are off or they stop working, then the capacitor starts to work because it's discharging. So we can say a capacitor is a device that stores electrical energy in an electric field. It is a passive electric component with two terminals. The effect of a capacitor is known as capacitance, and it's measured in farads. So, a capacitor is charging while the circuit is operating. Then it stores that energy in its electric field. The moment the circuit is off, or the moment the circuit is switched off, then a capacitor starts to discharge, meaning it's giving back the energy that it was storing back to the circuit. That's why it is always important to have that time delay whenever you are working on a circuit, because just because the circuit is off or is isolated, it doesn't mean that it's completely off, because the capacitor is doing its job, which is to discharge. And another thing a capacitor does, it affords that time delay. Have you ever switched off a TV, but the moment you switch it off on the socket, the LED of the TV doesn't switch off immediately. It switches off after some time. That's a capacitor discharging. I hope you guys understand that example. And we have two types of capacitors. We have a non-polarized capacitor and we have a polarized capacitor. By that, a polarized capacitor has a positive and a negative side, and a non-polarized capacitor doesn't have a positive and a negative side. You can connect it anyhow. On this slide, I'm gonna show you how to measure a capacitor, of which we don't usually do, because we get capacitors that are already rated, so there's no need for you to measure it. But if you don't know the value of the capacitor, or you need to measure it with the gray multimeter, of course, so you turn your dial selector to the F region. There is a F region on the multimeter, but always keep it in mind that whenever you are measuring an unknown value, you always select the higher scale, because you might not know what if maybe your capacitor is charged and it could damage the multimeter. So you select the higher scale, and then you insert your capacitor into the terminals. There are also terminals that are available on the gray multimeter, and then you move down the range to get the value, or to get the accurate reading of the capacitor that you're measuring. And remember, always put your values in engineering notation. Thank you.
So up next we have a power supply panel, which consists of a DC power supply just at the bottom there, an oscilloscope, the one with the bigger screen, and a function generator, just the one with the smaller screen underneath the oscilloscope, and an AC power supply. And then on the DC power supply, we have a power on switch, where you can just switch on the switch to switch on the power supply by pulling the toggle up, and you can switch it off by pulling the toggle down, and then your power supply will be on and off. Now this power supply, it's a dual power supply, meaning it can give you two power supply at the same time. You can have a positive supply, you can have a negative supply. You can use it to have two different voltage that are being supplied at the same time using the slave or the master.